We finished off the last video creating this histogram, so now we're going to describe the shape of the histogram. So this histogram is skewed left, and it has one peak. So it's unimodal. So the peak would be here, and it is skewed left, so it would go down to the left. Okay, so continuing on with discrete random variables. So we're going to do another example, and we are going to fill out the probability distribution, make a histogram, and describe its shape. So Mr. Sparks is thinking of offering a day trip tour and believes there must be at least 2 passengers for the trip to run, and the vehicle will hold up to 6 passengers. Mr. Sparks will charge $150 per passenger. So let C equals the total amount of money that Mr. Sparks collects on a randomly selected trip. So for 2 passengers, it would be $300. For 3 passengers, it would be $450. For 4 passengers, it would be $600. 5, and then 6 passengers would be $900. The probability of having 2 passengers is 0.15. Probability of 3 passengers, 0.25. Then we'll say 0.35, and then we'll go back down. So back down to 0.20, and then 0.05. All right, so the first thing we need to do is create a histogram of this data right here. So we can say, we'll just do same thing as last time, 0.1, 0.2, 0.3, 0.4, and then we'll do 300, 400, 300, 450, 600, my brain's on spring or fall break too, I guess, 750, 900. Okay, so for $300, the probability of that is 0.15, so it would be right here. This would be 3 passengers, 4 passengers, 5 passengers, 6 passengers. I'm just going to put that so I stop making silly mistakes. Okay, so for 3 passengers, it'd be $450, and the probability of that is 0.25. For 4 passengers, Mr. Sparks would make $600. That's 0.35. 5 passengers, 0.2. And 6 passengers rarely happens. That's just 0.05. So this histogram is a lot better than the one I did in the last video. So our shape here, you could say this one, I would say this is roughly symmetrical. So roughly symmetric with 1 peak. Okay, so now that we've gotten some good practice describing histograms and making histograms, we are going to do one of the biggest calculations that we've done so far in this unit, and that's going to be the expected value or the mean of a discrete random variable. We've talked about mean before. You know mean is the same thing as average. But we are going to be talking about the expected value of a probability distribution. So the definition will be the mean or the expected value of a discrete random variable is its average value over many repetitions of the same chance process. So the expected value may be designated by capital E, x, or mu of x. So this variable here is called mu, and that represents the mean of this discrete random variable. So say we have the discrete random variable x with the following probability distribution. So this looks very similar to the one we talked about earlier, where your value will be x sub 1, x sub 2, x sub 3, and your probabilities will be p sub 1, p sub 2, p sub 3, and so forth. The calculation for this looks complicated, but it's really not. The expected value is equal to the value times the probability plus the value times the probability plus the value times the probability. And that gives you the mean expected value. So luckily, we have several examples that we can do this for. The first example we can go through is the example with Mr. Sparks and his trip to Belize. So we have our values and we have our probabilities. So to calculate this, remember it's value times probability plus value times probability plus value times probability. So it would be 300 times 0.15 plus 450 times 0.25 plus 600 times 0.35 plus 750 times 0.2 plus 900 times 0.05. And you could do that in your scientific calculator, but if you're like me and forgot it, you will have to use the app. So we have 300 times 0.15 plus 450 times 0.25 plus 600 times 0.35 plus 750 times 0.20 plus 900 times 0.05. My expected value would be 562.5. 562.5. So that tells us that over many trips to Belize, Mr. Sparks makes an average of $562.50. So that's over several trials. So over several trials, we would expect Mr. Sparks to make $562.50 on average, which makes sense because our probabilities for 450 and 600 were the highest. So 0.25, 0.35 were the highest. So we would expect our mean value to be somewhere in this range. We can do this again. Why don't you pause the video and write out the equation for the probability of this distribution, just to get practice writing it on your own. Okay, when I wrote it out, this is what I got. So remember, it's value times the probability plus value times the probability plus value times the probability, etc. Now, just thinking about this, we should be able to determine what our expected value should be around. And by looking at these probabilities, my probabilities of getting an APGAR score of 8 or 9 are way higher than any of the other probabilities. So I am going to predict that when I put this into my calculator, I'm going to get somewhere between 8 and 9. And when I do, I get 8.128. So that means for several babies, the average APGAR score is 8.128. Now that we've talked about calculating the mean, we can talk about calculating the standard deviation. So the standard deviation, we can also use our probability distribution, and that mu of x, or the expected value, which is what we just talked about, is the mean of x. The variance of x is equal to, let me make sure I write this down correctly for you. So the variance of x is equal to the okay, so the variance of x is equal to the sigma squared times x, which is equal to your first value minus your expected value squared times the probability of your first value plus your second value minus your expected value squared times the probability of your second value, plus your third value minus the expected value, x, squared times the probability of your third value, and so forth. To simplify this, we would say the sum, so whenever you see the symbol, that means sum, of any value minus your expected value squared times the probability of that value. Now, I know that's a lot, but hang in there. The standard deviation is the square root of the variance. So standard deviation, or sigma of x, is equal to the square root of the sum of your value minus your expected value squared times its probability. And we're going to go through an example of this so you can see it in action. So go ahead and flip your page. All right. So let's look back at the random variable where C equals the total amount of money that Mr. Sparks will collect on a randomly selected tour in Belize. The two left columns of the following table give the probability of the distribution. Recall that the mean of C is 562.50, and we calculated that. Remember back here? 562.50 was what we got for our mean, or our expected value. So that's why they're subtracting it from all of these. The third column gives the table. The third column of the table shows the squared deviation of each value from the mean. So you have your value minus the expected value squared. The fourth column gives the weighted squared deviation. So the weighted squared deviation multiplies it by its probability. We can compute the variance by adding the weighted average of the squared deviations in the fourth column. So the variance is right here. They added all of these weighted squared deviations. So the variance is equal to 26,718.75. We can take the square root of the variance to get the standard deviation. So when I take the square root of 26,718.75, I get 163.45. So 163.46. We'll round that up. So what does the standard deviation tell us? Well, the standard deviation tells us that the amount of money that Mr. Sparks collects, so the amount of money that Mr. Sparks collects on a randomly selected trip typically varies from the mean of 562.50 by $163.46. So remember, the standard deviation is how far away you are from the mean. So if we get a standard deviation of 163.46, that tells us that we're typically vary from the mean that much. All right, so it says, knowing this about our data, which of the following prices is Mr. Sparks more likely to collect on a given day? So remember that our mean was 562.50. We want to be closer to that number. So we have to determine which one of these is closer, 572 or 862. Well, 572 is closer. 380.40 or 500. 550 is closer. 725.86 or 380. Let's see, which one would be closer? I might have to do some math for that one.